Welcome to part 6 of the Koch Fractals in Unity tutorial by PeerPlay. In this part we will create something similar to the visualization you see in the thumbnails of the tutorial. We will be using the audio peer class, which you can create following the audio visualization tutorial on the channel. We'll also be using the post-processing stack, which you can download and import for free from the Unity Asset Store. So in this part I will guide you through some steps that I've taken to create this 3D cube visualization that you've seen in the thumbnails. And the first thing we're going to add to our Koch line is a material that reacts to audio. So let's open up the Koch line. And let's add the material underneath the header audio. And we're going to type a public material, and we'll call this the material so we can select that in the inspector. And we're also going to need a color, so we're going to type a public color and we'll call this color. Now we're going to make an instance of this material, so let's type a private material and we'll call this material instance. Now to make this material run on audio, we also need to specify an audio band, and we're going to specify a multiplier of the color. So I'm going to type a public integer and we're going to call this the audio band material. And let's also type a public float, and we're going to call this the emission multiplier. Now let's set our line renderer to this material. So underneath here we're going to apply material. So we'll set the material instance that we created to become a new material, and this will create a new instance of a material. And we're going to use the material that we can specify in the inspector. And now we need to apply this material to the line renderer. So we're going to say that the line renderer, though its material, is going to be the material instance. And now in the update we can change the shader settings of the material instance to anything we want, and it will be applied to the line renderer. So let's go to the update. And let's actually go above the if generation count, because it's going to be always updating on the material. And here we're going to set the material instance, though it's set color. And if we're using the standard shader, which I'm going to use in this example, we need to specify here the emission color. So I'm going to change the emission color on audio, and we want to set it to a certain value. Now the value we want to set it to is the color that we specified, and we want to multiply this by the audio peer. So we're going to type the audio peer dot its audio band buffer, and here we require the audio band. So let's type in here the audio band material, and we're going to multiply this by the multiplier of the emission. And that should be all to make the color of the line renderer react to audio. So let's save that and go back to Unity. Now we need to create a material, so let's create a new material, and we are going to use standard, and we'll call this the Koch line standard. Now we're going to set this albedo to black, and we're going to tick on the emission so we can use the emission as we're setting this through script. Now go to the Koch line and drag and drop this onto the material, and we're going to set a color. Now I'm going to set this color to orange. We need to set the audio band material. Let's set this to 1 as well. And the emission multiplier, I'm going to set this to 4 for now. Now let's check out the result of this. Now we see that it goes to the color of orange, but it's not really reacting that much. So we're going to set up the camera first, and we're going to add the post-processing so we can see the emission multiplications. So let's go to the main camera, and we're going to add the post-processing behavior. And this requires a profile. So right click, create, and we're going to add a post-processing profile. and let's set up here some bloom. Actually, let me first add it to the camera, put it on there, and we can live see our result and change it. So I'm going to play the scene. So you can see already a lot of things happening. So the intensity, so now we can see some better results. Change the threshold. Alright, cool. So we've got a good start. Now let's continue and create a cool scene. So the first thing I'm going to do is fix this generator, because it's a little bit not going straight forward. So let's see what we've done here. This is at time 0.33 and this is at time 0.333. So let's change this to 0.01 and that should make that a bit better. Here we've got 666, so let's change this to 6659, and now that should work a little bit better. Now what I did in the visualization is that I stacked a couple of these lines on top of each other and then I built a cube out of them. So let's copy paste these 2 times. So we've got 3 different line renderers here. And now I'm going to change each of these line renderers to have a different amount of generations. So the first one will have a generation of only 1 generation. And that will go inwards with a scale of 1. The second one will have the 2 generations that are already set up. And the third one will create 3 generations. And I'm going to set this outwards like 3. Now let's see that. So now we've got this as a result, but they're all still the same colors, so we're going to change them to different colors. We can do that right now, but then Unity will reset. So let's quit the scene and then set the colors of all these lines to something different. So what I want to do is I want to set the one with 1 generation to become something like red. So I'm going to set this to a red color and not make it entirely red. And the one with 2 generations, that is going to be blue. Let's make that blue. Now let's see the result of that. Nice. Now they're still all working on the same audio band, so we're going to change that as well. So let's say that the red one will be on the bass. So let's change this to 0. And we're going to change this to 0 as well. Let's change the blue one to 2. And I'm going to change this one to 5, which is a bit higher frequency. So now they're all reacting to different frequencies. Let's see the result of that. And maybe what would be cool if they are different sizes. So let's change the red one and see what the result would be of that if we create a different width of this. So let's change this to 2.5. That's pretty cool. So let's change that to the red. We're going to set that to 25, 0.25. So then this will be the result. Now we need to copy these 3 lines together 6 times so we can create a 3D cube from line renderers. And to easily set up the cube, we need to get the length of this line, and we don't have that line yet because we've got the length of this diagonal line from the center towards this point, which is at 10 at this point. So I'm going to go to the Koch generator and we're going to quickly add something so we can see the length of that line. So let's go to the onDraw gizmos, and I'm just going to type above the onDraw gizmos a public float, and we're going to call this the length of sides. So let's go underneath here, and outside of this last for loop in the onDraw gizmos, we're going to type that the length of sides is going to be a distance check from its 0 point to its first point, so we can get the distance. So let's say vector3 the distance is going from the initiator point of its 0 towards the initiator point 1. And to get the value that we need for building out our cube, we're going to divide this by 2. So I'm going to multiply this by 0.5. Now let's save that script and go back to Unity. And now we've got a number of the length of sides here. And if we change the initiator size, you can see that the length is changing to its corresponding size. So let's change it back to 10. Now what I'm going to do is create a new empty game object, and I'm going to call this the cube, and this will be at 0, 0, 0. And this is one side, so let's also store that into another empty game object. We'll call this side, and let's all make them child of this side. Let's set them to position 0. And now let's make the side a child of the cube. So this is going to be the first side, and we need to set this to 0, 0, 0 as well. Now what we need to do is we get the number that we've got here, and we can copy that, and we can use it on the side. So this is going to be the base one, so let's change its Y position to that number. This will be the top then. Now let's copy paste that side, and we can make this a minus. Now we've got the top side and the bottom side. Let me actually change this surrounding to turn off so we can see it a little bit better. So let's copy paste side 1, and we're going to set this Y positions to its 0 position again. And in the Koch line we can select them all and change the axis to its X. Now for this side we'll apply it to its Z-axis, as you can see the blue arrow here. So we're going to apply that number on its Z-axis, and that makes that side exactly aligned with the others. Now let's copy paste this side again, so Ctrl D on this, and we can simply change this value to a minus value. Now we just have these other two sides left, so we can copy paste this one again, and we're going to change its axis to the Y, set this position to 0 again, and now we just have to apply the X value, so we're going to put that to 7, copy paste this side again, and just fill in here a minus value. And now we've got all these 6 sides filled with the corresponding sides, and we've got the cube here that we can change of its position and its rotation. And now with this cube set up, let's see what it looks like. Let's put the camera a little bit more to the front, and we can rotate this cube around, and you can see a very nice cube with a lot of different line renderers. So before I'm going to duplicate this cube, we're going to set all of these Koch lines a child of the cube itself. So we can remove the other objects. So let's do this one, these sides as well. Make them child of the cube. Now we can remove these sides. And now let's duplicate this cube. And we can change this to its size, a little bit bigger. Now what we can do with this cube, we can change the colors of these lines. I'm just going to change all of the colors to a different color, because I'm a little bit lazy. And I'm going to change this to pink. So now we've got an outer cube with only pink colors. and an inner cube with a lot of different colors. Now we just need some kind of a rotation script, so the camera will move around of the center cube on audio. So let's create a new empty game object, and we're going to call this rotate cam. And I'm actually going to make the camera a child of the rotate cam. And let's call this rotate cam, another script. Let's open up that script. And this script requires the audio pair, so we're going to create a public audio pair. And we'll call this audio pair. We need a rotate axis and a rotate speed, so we're going to create a public vector3, and we'll call this the rotate axis. And let's also create a rotate speed. And we want our camera to always look at the center of this object, which will be at the center of the center cube. So we're going to say that transform dot is get child, and we're going to get its first child, which is the camera, dot its transform dot look at, and we're going to look at this dot transform. Now we want to rotate this transform, so we're going to say that this dot transform dot rotate. So on its x-axis, it's going to require the rotate axis dot x multiplied by the rotate speed, multiplied by time dot delta time, so we always get the same amount at the frame rate. And we're going to multiply that by something from the audio pair class. So we've got the audio pair, and let's see what we'll do. We'll get the amplitude. So let's say amplitude buffer, and that is all for the x-axis. Now we also need the y-axis, so let's copy paste this entire line and paste it here. Let's paste it again, put a comma here, and this is going to be its y. And I forgot to specify the x value here. Also got to have the y value there, and we also need the y value, or the z value there. This is going to be z as well. So we've got x, x, y, y, z, z, and that should all work. Let's put this behind this line. Let's save the script and go back to Unity. Now this rotation cam is going to be at 0. The main camera is going to be a certain distance. Let's set it to here. And we need to specify the audio pair class, so let's drag and drop that into there. Now we need a rotate axis. Let's say it's rotating around its y-axis with a rotate speed of 200. Now let's actually also rotate in its x-axis. So let's set that to 1 as well. And I'm going to set this to 100. Now let's see what that looks like when we play the scene. So I've shown you one of the possible results to create with just the Koch line renderer. Hopefully you learned something from our workflow. In the next part we will create a Koch Fractal system based on trails, which is even cooler than the line renderer in my opinion. And what's even cooler if you combine them together in a visualization. So stay tuned for part 7 and 8. But for now I want to thank you for following this tutorial. If you would like to support me creating these tutorials for free, become a patron on my Patreon, and you get access to the source code of this tutorial. If you like this video, leave a thumbs up, and to stay updated for new release parts, subscribe to the channel.